We looked at the differences between narrative reviews, systematic reviews, and meta-analysis. Now, given a forest plot, interpret the results of a meta-analysis, which is the course learning outcome number 4 on the course syllabus. A meta-analysis provides a best estimate of effect, which is usually called a summary or pooled estimate, and it's from the weighted averages of the results of the individual studies in the meta-analysis. In other words, every study in the meta-analysis has a different weight on the pooled estimate. Now, this weighting process depends on the sample size or number of events, or more specifically, study precision. So when applying research evidence to a clinical question, you should determine whether clinical action would differ if the upper or the lower boundaries of the confidence interval represented the truth. If the clinical decision is the same, whether the upper or lower boundary of the confidence interval represents the truth, then the evidence is sufficiently precise. If across the range of the confidence interval values our decision making would change, then we would have less confidence in the evidence and lower the confidence rating. So studies that are more precise have narrower confidence intervals and larger weight in meta-analysis. Now, when it comes to the outcomes that we can pull in the meta-analysis, there are two types. We have dichotomous outcomes and continuous outcomes. So the dichotomous outcomes, which is basically a yes or no outcome, for example, mortality, so someone either died or survived, so that's a dichotomous. And when we aggregate the data, the outcome will be reported as relative risk or odds ratio, or in the case of time to event, we will have hazard ratio. Now, when it comes to continuous variables, such as the length of hospital stay, meta-analysts typically use one of two options to aggregate data across studies. So if the outcome is measured the same way in all of the studies, we can actually use weighted mean difference. And if the outcomes in the studies are similar but not identical, what the analyst can do is to divide the weighted difference by standard deviation to standardize it. So then the results will be reported in standard deviation units. Generally speaking, a 0.2 standard deviation represents small effect, 0.5 moderate effect, and 0.8 represents a large effect. The results of meta-analyses are usually displayed in a forest plot. So in a forest plot, which I will show you in a minute, it shows the effect, which is basically the result from every study. The point estimate from each study is presented as a square, and the size of that square is proportional to the weight of each study. And then the confidence interval is presented as a horizontal line. It will also show you a solid line of no difference. So if the outcome is a ratio, the line of no difference would be 1. And if the outcome is a difference, in effect, no difference would be 0. And sometimes a dashed line will be centered in the meta-analysis combined summary effect, just so you can compare individual studies to the overall effect size. And of course, if the confidence interval includes the line of no difference, the results are not statistically significant. And then once we aggregate all of the studies results, the combined summary effect is usually presented as a diamond, with its width representing the confidence interval for the combined effect. Let's take a look. So this is an example of a meta-analysis. So you can see they basically list the different studies included. So this is study 1, this is study 2, study 3, study 4, study 5. And then this is the line of no difference. The outcome they're looking at is an odds ratio, so 1 would be no difference. And then they're showing you the results for each study. So for study 1, you can see that this square is the actual effect size for that study, and the size of it shows the weight of it. So you can see this is a moderate weight of that study, and then this is the confidence interval. So for this study, the results are not statistically significant because the confidence interval includes line of no difference. And then the second study, which also included 1 in the confidence interval. So here on the right hand side, it's showing you the numerical value of the confidence interval, and on the left, it's showing you the visual presentation of the confidence interval. So this one has a very small weight, so you can see the score is very small, and it did touch 1, so it's not statistically significant. The third study also is not statistically significant as it includes 1. And then the fourth and the fifth one are statistically significant. As you can see, the confidence interval does not include 1, and they have a very large weight. So you see the score is very big, so they have large weight. And then at the bottom you have the summary. So once they aggregate all of the studies, now this diamond is the actual effect size when you combine all of the studies together. So the center of it, which is this dashed lines, is what they actually found. So 2.2 is the odds ratio for the overall effect size, and then the width of the diamond is the confidence interval. So it goes from 1.9 to 2.4, and because the diamond does not include 1, which is the line of no effect, the results are statistically significant.